The derivation sheet serves as the theoretical foundation or engine, while the sequence and block diagrams illustrate how that abstract engine is practically applied to solve real-world problems. Relationship with the sequence diagram. The relationship here is one of logical progression. The derivation sheet establishes the fundamental rules, such as defining curved paths and straight rays and creating the formulas needed to translate raw sensor data into meaningful positions. Initial mapping. The derivation sheet provides the basic geometry that the sequence diagram uses as its starting point. Translation layer. The diagram shows how those abstract mathematical variables are handed over to physical theories, where they are assigned practical meanings like speed or time delays. Validation. The sequence diagram uses the mathematical proofs of how non-standard grids behave to power visual simulations, which ultimately confirm that this system is the ideal tool for tracking things that remain constant or measuring specific differences. Relationship with the block diagram. The relationship here is one of structural connectivity, where the derivation sheet provides the genetic code for different functional blocks. The theory block, the mathematical properties defined in the derivation, such as how lines of constant value form specific shapes, are linked directly to different physical fields like high-speed physics, navigation, or fluid flow. The logic block, the derivation's proof that the coordinate grid is not composed of standard right angles, provides the visual logic for the simulations. This explains why, in certain demonstrations, the grid appears to warp or squash toward a specific limit. It also provides the specific mechanism used to pinpoint where two curved paths cross to find a location. The fulfillment block. This represents the final resolution of the math. The derivation's conclusion, that this is a non-standard way of measuring space, is fulfilled when complex engineering shapes are straightened out into simple problems or when distances in high-speed environments are proven to remain unchanged. In summary, the derivation sheet provides the mechanics, while the diagrams provide the map and the timeline for how those mechanics solve for physical certainties.